Alright, so today we're going to start with truss analysis and we're going to start with analyzing simple trusses. Now, before we start analyzing the trusses, we've got to remember the three equilibrium mechanics principles. That is, the sum of all moments is equal to 0, the sum of all horizontal forces is equal to 0, and the sum of all vertical forces is equal to 0. We know this to be true as the bridge is stationary and not moving. If we analyze the following truss, we can see two forces acting on it. One force is acting vertically to the truss with 225 newtons. The other is acting at an angle of 30 degrees from the horizontal with 250 newtons. The first step with solving this truss is splitting down the forces into horizontal and vertical components. This can be simply done with basic trigonometric ratios, where we can determine the horizontal component to be 250 multiplied by cos 30 and the vertical component to be 250 multiplied by sin 30. We also need to calculate the perpendicular distance of the forces in relation to the fixed pin joint. We can calculate the perpendicular distance of the horizontal force using basic trigonometric ratios, as seen to the right. If we assume each truss member is 1 meter long, we can use a simple trigonometric ratio of sine 60 equaling to x over 1. In this case, x is equal to the perpendicular distance of the horizontal force to the fixed pin joint. When we rearrange the formula and plug it into the calculator, we can see that the perpendicular distance is 0.866 meters. Now that we have all the perpendicular distances of all the forces, we can begin taking moments. Remember, moments are just an example of torque, which is force times the distance. By this we can see that the sum of moments is equal to 250 cos 30 multiplied by 0.866 plus 250 sine 30 multiplied by a half plus 225 multiplied by 1.5 minus 2 times reaction at support number 2. Since the sum of moments is equal to 0, we can rearrange the equation to get the resultant at reaction number 2. In this case, the resultant is 293.75 newtons vertically. But how do we solve for the reactions at resultant number 1? Remember your 3 rules of equilibrium. We can use these equations and rearrange them to calculate the resultant horizontal and vertical force in the remaining reaction. To do so, we simply use Pythagoras' theorem in order to calculate the side of the hypotenuse, which in our case is the resultant force. We also may use an inverse trigonometric function, in this case tan, to calculate the angle of the resultant, in this case 14.56 degrees. Now we can see that we've calculated both reactions, with the reaction at the roller joint being 293.75 newtons directly vertically, and the reaction at reaction 1 being 223.7 newtons at an angle of 14.56 degrees. And this concludes today's introduction to basic truss analysis. Once you wrap your head around the basic rules, the process becomes second nature.